In this video, we're going to have a look at the AsyncTask class. So before I get to the explanation of what is the AsyncTask class, let's just look at an example and why we can then go after this example and say we need to use something like the AsyncTask class. So what I've done so far is to create an application called AsyncTask Example 2019 Video. That's the name of my application. It's a blank application. And what I've done is to add these three components to the screen. So it's a normal edit text, it's a normal button, and a text view. So for the edit text, I call it ET dice. For the button, I call it BT and roll, and the text on it roll dice. And for the text view, it is called TV results. And then on all three of these, you can see I've set the margins on the end and the start 30 and the top 10. So it's basic stuff, and I don't want to waste time again on the video to create just this simple layout. So please try and create this layout on your own, just an edit text, a button, and a text view, just to see how it works. And then in the main activity, I have set up those three components. There's the declarations for the three. I've set those three up using the find view by ID method. And then I've set the on-click listener on BT and roll. Okay, so let's just see what I've done in the button part, because this is also very straightforward, but let's just quickly go through the coding. So you can do the set on-click listener for your BT and roll, and then also just type these lines in there. So it's going to be int 1s equals 0, 2s equals 0, 3s equals 0, 4s equals 0, 5s and 6s equals 0. So what we're trying to do here, if I quickly run this app, is we want to see how many times a specific, let's say a 1 or a 2 or a 3 will be rolled. If, for example, we could roll a dice 100 times, and if I click on roll dice, it will tell me if you roll a dice for 100 times, then the chances are that you could get this type of result, where on the ones it will be 22, on twos 14, 15, 17 and so forth. If I roll it again, obviously it's going to be different. So we're simulating basically rolling a dice here, and every time you roll it you will get different values, but it will be near to the same values. So how do we do this? So basically I will say that the ones, we're going to start with 0, and 2s and 3s and 4s and 6s. Well, all 6 of them will start at 0. So if you start rolling the dice, we start having a count on every one of them. So the number of times we want to roll the dice we get from the user from this edit text. So I'll basically say etdice.getText.toString, but then this part is now in a string, and we want that as an integer. So we need to convert it to an integer by saying integer.parseInt, passing in what the user typed there. So the 100 there will be as a text 100, and that needs to be converted to an integer, so it's 100 that we can work with. So then I'm using the random number generator to generate a number for me from 1 or from 0, yeah, basically from 1 to 6. I'm going to explain this part now. So I'm setting up a results variable there just to print out the results at the bottom, and then I run a for loop the number of times that the user indicates. So this for loop is now simulating how many times we will run this, or basically throw the dice. So the user told us how many times we should execute this for loop, or how many times we should roll the dice, and that's the same number of times. So if I entered 100, then this number of times will be 100, and this loop will execute exactly 100 times. And every time it executes, it will get a new random number. So I'm saying here random number should be this, using this random class of Java, using the nextInt method. Now the nextInt method accepts a value, and then your random number will be generated from 0 included up until the value that you give here as the bound not included. So if I pass in a 6 like in this example, then this random class will give me an integer value between 0 and 6 excluded. 0 included, 6 excluded. So your random value will look like this. It will be either a 0 or a 1 or a 2 or a 3 or a 4 or a 5. That is the random number that will be generated. So if the bound is 6, then it's 1 less than 6, which will be included. So it's going to give me values of 0, 1, 2, 3, or 4, or 5. And then I'm just adding 1 there, which means that the random number that will be saved into random number, this part there, will give me the random number of 0, 1, 2, 3, 4, 5. The plus 1 at the end will just add 1 to that value. So if it generates a 0, it's going to be 1. If it generates a 1, it's going to be 2. If it generates a 2, it's going to be 3. And so it carries on. And you'll see that at the end, we will either have a 1, a 2, a 3, a 4, or a 5, or a 6 that's saved into the random number, which is exactly what we will get on a dice. Right, so this is just some basics on Java and how it does random numbers, but this is how you can do the random number generator to simulate rolling a dice. And then we take this random number, which will be now a 1, 2, 3, 4, 5, or a 6, and we pass it into the switch and test for a 1, a 2, a 3, a 4, a 5, and the default will be our 6. And then every time it runs the loop, we get that random number, so that's like rolling the dice, see where it landed, and then add 1 to 1s or 2s or 3s or 4s or 5s or 6s, depending on which value then came into the switch. And then right at the end, you can see that we set the results, and we will print out to the screen results, show the number of 1s, the number of 2s, the 3s, the 4s, the 5s, the 6s. We will set it then to our text view called TV results, and then we will show a toast saying done. So this is basically what we're doing just to simulate rolling a dice. And if you look at that application again, this is exactly what we're doing. Clicking on it and it rolls the dice. If I say 100 there, it will run this for loop 100 times, getting a new random number again from 1 to 6, checking which number it was, adding it to the specific value, and then give me the results. And there you can see the different results. So if I make this a bit more, you can see it gives you, out of this 100,000 rolls, I will have about 16,000 times I will have a 1. So this is a lot faster to run or to roll a dice 100,000 times than physically doing it with your hands. So let's just have a look at this application now. If I keep on adding zeros there, you can see it's quite fast. That's fine. Add another 0 there. You can see it lagged now a bit. Now see if I add the next 0. It seems as if my application is stalling now. You can see the button. Seems as if something's happening with that button, but something actually happened in the background. But it's now just running that for loop so many times that it's actually now lagging my whole application. So if I add another 0 there, you'll even more see the effect. You can see there, even if I try to click there, I can't do anything now on the user interface because there's something running on the user interface that is taking up a lot of time there taking a lot of time on the user interface, and that it seems now as if it's blocking whatever the user will want to do further on this application. So you can see it seems as if the application is now hanged, but if we just give it a few more seconds, you'll see that it is actually doing something in the background, and it will show done here as a toast, and it will give you the new results. It's just taking really long because we're running that loop this amount of times. And there you can see done with the result. So it wasn't your application that's stalling. It was actually just doing something in the background. And if you go on further, this is now because I've entered probably a long value there, gone over the size of integers. But in most of these emulators, and even on your phone, when you do something that takes a lot of time, it will sometimes pop up a little box there telling you that this application is taking very long now. Should it shut down the application or wait? And that's something you don't want on your applications as an Android developer. So let's see what we can do to overcome this problem and maybe show type of progress for the user. At least then the user will know that something is happening in the background, although the application cannot continue. Well, your application will actually be able to continue if you do it that way. So let's see how the async task can help us to do or to run something in the background instead of running it on the user interface thread. So this is the user interface thread that you can see here, and currently we're running everything on the user interface thread. So if something takes a lot of time on the user interface thread, it will seem as if your application is hanging, and we don't want that. So let's look at the async task. So if you go to the developer's website, so it's developer.android.com, reference Android OS, and then you can see async task. So if you go to the top there of async task, you can see that async task enables proper and easy use of the user interface thread. This class allows you to perform background operations and publish the results on the user interface thread without having to manipulate threads or handlers. The async task is designed to be a helper class around thread and handler and does not constitute a generic threading framework. It should ideally be used for short operations, a few seconds at the most. If you need to keep threads running for long periods of time, it's highly recommended that you use various APIs provided by the concurrent package, such as executor and so forth. So the asynchronous task is defined by a computation that runs on the background thread and whose result is published on the UI thread. As asynchronous task, or an asynchronous task, is defined by three generic types called params. We're going to have a look at that now: params, progress, and result. And four steps called on pre-execute, do in background, on progress update, and on post-execute. So we'll look at this class, and basically on pre-execute is still in the user interface thread. Do in background is now in a separate thread, so it doesn't slow down your user interface. So our whole computation and the for loop running the dice we will do in the do in background, so it doesn't slow down my user interface thread. And then on progress update is also run on the user interface thread, and on post execute also on the user interface thread. So it's only this method that basically goes into the background. And then you can see there's some example coding on how you can use it. They talk a bit more about the generic types, the params. You'll see that when we create the async task, it looks something like this. Extends async task, and there's the three generic types. And we'll look at the three generic types, which will be the parameters that will be passed into this class when we start it. There's also the type for the progress bar that you're going to use, and then there's a result, which will be the return type when the background process is done. And then they also explain the four steps: the on pre-execute, do in background, progress update, and the on post-execute. So let's have a look at how we can implement this async task now in our application. So let's go down to the bottom, and just before your closing activity tag there for the activities opening bracket there, and the closing bracket, so in between there, we're going to create this class. So I'm going to say it's a public class. We can actually use this class as private also. So let's say private class, and let's call this one run dice in the background. Let's call the class this run dice in background. Now we're going to say extends, and then we're going to indicate we want to use the async task. And you can see there's the generic types: params, progress, and result. So for this specific example, I'm going to indicate the types as integer, integer again, and then the last type is a string that we will be returning back. So to just quickly have an indication of what happens here is this integer there, this type, is the type that we will pass in right at the beginning. And what we want to pass in is actually an integer to say how many times do we want to run this loop. So that's what we're going to pass into this class, the async task class. So that is basically the type for what you're passing in right at the start. So I'm going to say I'm going to pass in an integer. The second one is basically how do we update our progress bar, and we're going to use integers to do so. So that's the second type. And then the third type there is what will be returned right at the end when everything is done. And what we want to return is this results, which means it's going to be a string that we're going to return back. Now, if you click on it and say Alt-Enter, you can say implement methods, and the only method that you must have here is the do in background method. So I'm just going to remove all these comments, but you'll see there is your do in background method. That's the only method that you must have as part of your async task. So I'm going to add the other methods as well. So you're going to right click there and say generate, go to override methods, and there you can see all the rest of the methods that's part of the async task. So the first method that runs when you start your async task is your onPreExecute method. So if you open up that method, you can also see it says it runs on the UI thread just before doing background. So this is the first method that runs. So we will start with onPreExecute, and this is where we can initialize stuff and so forth just before we go into the background. Then the doInBackground method goes into the background, and then while we are in the background, we can have a method called onProgressUpdate. Now this method runs also on the user interface thread, so it can update your progress bar on the user interface thread. And then your last method that will execute here will be your onPostExecute method. And you can also see it runs on the user interface thread. So all of them basically runs on the user interface thread except for your doInBackground method. So what happens now, when we start this async task, you can see there's the type integer. That integer gets passed into your doInBackground method here. So you can see the type will automatically be the same. This integer there that you indicated for the second one will be your progress bar's integer values. So we'll, when we update the progress bar, you'll see that we're going to use those values. So that's where this integer goes to. It's basically the type that we indicate here. For this one, it's the type that we indicate what gets passed into the doInBackground method. And then your last one there, the string, you can see it's what your doInBackground method returns back. So it depends on what you set these three values on what these methods will return then, or will basically accept. So this one is the return statement for your doInBackground, and your doInBackground automatically returns back to your onPostExecute, which means that this string there is also the return type for your doInBackground, but it's also the one that your onPostExecute will accept. So if you return your string there, that value gets returned as the S there, and you can then do something with it. Right, so let's move our code a bit. I'm going to take this coding that we had here. I'm going to take everything here. Let's take everything that was part of this. I'm going to cut it from my btn role. And then I basically want to do all of that inside of my doInBackground method. So just paste it inside of your doInBackground method. So now the number of times here, you can see that trying to get etdice, you can't get anything from the user interface thread done inside of your doInBackground. So our number of times here, we should get on a different way. So I'm going to remove this line, and we'll look at that part now. So for the rest, this is fine. We will have our 1s, 2s, 3s, 4s, and 6s declared. We'll have the random number. We're going to look at number of times now, how we can do that. Our random number will be generated. We will run that for loop for that amount of times. We will set up the results, but again, we cannot set anything on the user interface thread from the doInBackground method, which means this line cannot work there. And also it will throw an exception when trying to do your toast also. So please remove everything from the user interface thread from your doInBackground method. So now this results that was set up, we will return this results, which means that this results will ultimately get returned back into your onPostExecute, and then we can do something with it. So let's just see how we can do this number of times now, because that's our only problem. How can I see what is the number of times this thing should execute? So the way that we call your async task is just calling new run dice in background, and then you call .execute. So when you talk about passing in this last, that's the first one. So if you talk about passing in the integer there, the type, that's the one that gets passed into your doInBackground method. So if I pass in an integer there as 1, that is actually what I'm passing in now into the doInBackground. And you can see these 3 dots. It means that it's basically accepting an array of values. So I can pass in 1, 2, 3, 4, 5. And all 5 values will then be passed into integers there as an array. And let's say I want to have the 1 there, then I'll refer to here as integers at position 0, for example. So you're able to pass in as many values separated by commas into your doInBackground method, and it will sit into this integers array. Okay, so basically what we want to do is we want to only pass in one value. Let's say we want to say this loop should execute 10 times. Then we're passing in 10 there, which is only one value, which means we're going to get that value at position 0 in this array that was passed in. Okay, so obviously we're not going to pass in 10 there. We want to go to etdice. Let's just convert that to an integer also. So we're going to say integer.parseInt, and we're going to go to etdice.getText.toString and maybe trim it. So what does this part do? etdice.getText.toString.trim. It gets the value that the user entered, convert it to an integer, and that is the value that we passed into the execute method, which means that's also the value that gets passed into this array. And because we're only passing in one value, that one value we can get at position 0. So now, when this thing executes, it will run this for loop the amount of times and push out the results into your onPost execute. So now in your onPost execute, you've got access to your user interface again, which means I can then go to TV results and just set the text. I'm going to call set text and pass in that S there, and we can see if that worked, and then also display the toast here that we previously did to just say done. Now let's see if this works now. So just remember, while it's running now, what will happen is onPre-execute runs first. We're not currently doing anything in onPre-execute. We're going to look at that now. So when it starts, you can see that we're passing in the integer there. It goes into the doInBackground method. It executes this, builds the results, and then return the results. Where does it get returned to? Into the onPost execute to that S. And that's the one we then print out. Remember, in the onPost execute, we are back at the user interface thread, which means we can set TV results, we can show toasts, we can get information, whatever. We are done in the background. So let's see if this works. Right, so there's the app. I'm going to type in 1000 there. Let me just run this again. I just want to make sure that we've got the newest version now on that phone. Right, so there it runs. Let's see. So I'm gonna put 10,000 there and say roll the dice. You can see everything still works 100%. I can do it again. It's quite fast. Even though it seems now the same as the previous program, we're actually doing it now in the background. So you can see now, if I do this now a lot of times, it's done. Let's add another 0 there. You can see the button is now, and the edit text is still working. I can still do something in it, although it's busy doing something in the background. Even if I put another 0 there, you can see, well, it seems as if nothing is happening, and we'll change that now. But at least my user interface is not hanging. You'll see the done pop up now and the results being changed because it's still in the doInBackground method. As soon as it's done in the doInBackground method, it will return results there, and it will set the results and show the toast. But you can see my user interface is not hanging currently. Right, so let's see if we can do something like a progress bar here. So what I'm going to do is I'm going to go to my activity main XML, and you're going to search there at the top, search for progress bar. And you can see there's two types of progress bars that you can drag in. There's the horizontal one, and there's just a normal spinner. So in some instances, the spinner works better. In some instances, this progress bar works better. So it depends on what you want to do. So I'm going to drag in that one right at the top there of the screen. So you'll see it will basically be there at the top of the screen, and the user will see that progress bar. So I'm going to click on it, and I'm going to call this one, let's leave it progress bar, that's fine. Let's go into the main activity and set up that progress bar. So it's like setting up any other component. So we're going to call it progress bar. And then go to setting it up also with the find view by ID, r.id.progress bar. Now where we want to set up this progress bar, we can do this in the onPre-execute now. So in the onPre-execute, we can go and say progress bar dot set visibility, and we start showing this. So I'm going to say view dot visible. So obviously somewhere right from the start, after we've declared it there, I'm going to set the visibility to gone so that the user cannot see that progress bar right at the start. And then when we call this, go and run it in the background, we set the visibility to visible so that the user will start seeing that progress bar. Now, there's two types of progress bar also here. You can see there that we can set a property that says indeterminate. And now if I set this property to true, you will see when we start running this, let me just show you quickly. If I run and I say OK, remember it will start showing when we click on the button. Right, so there it runs, and let's take a big value there and say roll dice, and you can see that is basically where your indeterminate is equal to true. You can see it just runs over the screen like it's loading something. Okay, so that, if you want to do something like this, then you just set it to true. And then when we're done, we can actually go back to, let's go to, so we're going to set it visible on the pre-execute, and then when we're done here, we can set it the progress bar, you can set the visibility back to view.gone. Okay, so let's just try out that one quickly. So I can now go and say, let's roll the dice this amount of times. You can see it shows at the top, and when it's done, it stops showing. So that is when we set this value. If we go back to test or text, you can set the indeterminate to true. So what we're going to do here is to set it to false, which means that we will give it values on how far it should show the progress here at the top. Okay, so this is important for this example, that you should set your indeterminate to false, and which means that we will update how far it goes in the progress bar. Right, so that's just hiding and showing your progress bar at the correct places. Right, and then for the progress bar, if we want to do it this way, where we set our own progress, we're going to set the maximum value there to a specific value. And now the maximum value, because we are still here in the on pre-execute, we are still in the user interface thread, we can actually go and get exactly the same value there. Let's take this one as your maximum value, which is whatever the user typed. That should be your maximum value for the amount of times that the user rolled the dice. So that will be my maximum value. Now if we go down into the do in background method, we need to set the progress on this progress bar ourselves. So we need to think about a bit about this process. And what I'm going to do here is I'm going to have a double that declares the current progress. And I'm going to set that to 0. And then we're going to have the previous progress. And I'm going to set that to 0 as well. So in some cases, when you're running your progress bar for too long amount of time, it could really slow down your application. So we don't want that. And that's why in most cases, if you set this indeterminate to true, will be a better value to do, unless you want to show a specific progress. So what I'm going to do now inside of this for loop is I'm going to set, just before I do the random number, I'm going to set the current progress. Obviously this value of I divided by this number of times that we want to roll the dice. So you agree as a percentage. Let's say we're running this, let's say we're running this 100 times, and the loop is currently at 1 out of the 100 times. So if we look at a percentage on how far this progress is, it will be 1%, basically 1 out of 100. But remember that you get integer division if you use the division operator with 2 integers. So just one of the 2 sides, make sure that you convert it to a double. So the current progress where we are currently is fine doing it this way. And now basically I can just set this current progress to update. But it will slow down my application. So if you want to do this, let's say every 2% update the progress or whatever, we can do it like this. We can say if the current progress is, or minus the previous progress, is greater than or equal a specific percentage value. So I'm basically checking if 2% progress has been achieved, then I will publish the progress. So to publish the progress, you use a method called publish progress, and you can pass in the value that you want to publish. So let's say we are now at 2 out of 100, then I want to publish it. So I'll publish that 2, and my progress bar will move that bit 2% every time. Okay, just to make sure that it doesn't slow down the whole process. So now for the published progress will then be I. and then I'm going to set the previous progress should be this current progress now. So then we know we've got a current progress, and then when this for loop runs again, or we've got a previous progress is equal to the current progress. So when current progress works out again, that value will change now to maybe 3 out of 100, but your previous progress is still 2 out of 100. So when you deduct, it will be a difference of 0.01, not 0.02. The next time the for loop runs, it goes to 4, and your previous progress is still at 2 over 100, which means that if you deduct then, you'll get that 2 difference. So then it will publish the progress. So I hope this makes sense. It's just a way for me to basically show the progress every 2% instead of showing it every single time. So what we could have done is to just call publish progress and then pass in the I, and it will work 100%. But if you run this too many times, that progress bar could start slowing down your application. So maybe then if it gets too high, you can do it every 5% update. So this is really up to you. Obviously, the less times you update it, the faster your application will run. Okay, so let's set or publish the progress then every 2%, 0.02, and then basically where it runs, if you call publish progress now, it's going to pass into this on progress update, and your value will be passed in there, which means then if I pass the I there, which is an integer, I will pass that 4 or whatever, wherever it is, I'm passing that 4 to this values. And again, you see the 3 dots there, which means I can pass in I, 2, 3, 4. I can add any number of values there, but we are only interested in one value, and that's the I there. Okay, so we're passing in one value there. So you agree then that we'll get that one value at values position 0. That's where we're going to get that value. And now it's very easy. What we want to do then here with that I is we're going to call the progress bar. So remember, on progress update is again in the user interface, so that I can call it from here. So I'm going to say progress bar dot set progress, and the progress I want to set, well, it's passed in through this values, and it will be at position 0. And now I'm setting my progress. So let's see if this one works. If we run it now, I'm going to stop it and run it again. Right, so here we see the application. Let's run it, let's say that amount of times, and you can see how the progress bar now works out the progress until it's done. And this one is now moving every 2%. So we can go and say, well, let's do this one every, let's say 5%, and run it again. And you see it's going to move bigger parts, but not update as often. So let's just see if it runs again. Right, let's add a big value there again, run it, and you can see it updates now bigger parts. Still fast. Let's add another 0 there. You can see it waits a bit, and then it updates every 5%. Now, if you look at this again, you will see that it starts, if I start rolling the dice, it starts with some value and then it moves back. Now, look carefully. If I click there, you can see it started there and then it starts back at the beginning. So very important here that when you go and you set up your progress bar, that we will set on the progress bar also, we're going to set the progress to 0 to make sure that every time we run this, the progress will be set to 0 from the start, and then you won't have that thing at the beginning. All right, so let's try this out again. Roll the dice. You can see there it goes. Add another 0 there. You can see it starts nicely from 0. It doesn't have start with one that starts there and then goes back. 100%. Click it again. It starts from 0 again. Right. So this is now basically updating every 5%. What we could have done is to leave out all of this, take it away, and we could have just called publish progress and pass in Y, which means that we are really publishing every single time this for loop is running. So that's also fine. You can do that if you know that the number of calculations won't be that much. But in this case, you will see it actually slows down the application. So let's see this one quickly in action. Let's just take 10,000 for now. You can see how long this 10,000 even takes to execute, because it's now waiting. Let's add another 0. It's actually waiting for this progress bar to complete. because it needs to display the whole time on the graphical user interface. So this is not a very good way to do this. If it's only 100 times it runs, yes, then it's fine. You know, let's just go to 100 there on the next one. But you can see this progress bar is going very slow. So that's not what we want here. Let's just see this one again. So for 100, that's quite fast. I mean, you don't even see it. For 1,000 even, it goes quite fast. So it's better to go and work with a percentage there, so that you know, for example, this one, every 5% it will update your user interface. So it's not that frequent updating to your progress bar the whole time. So let's do 10,000 again, and you can see how fast that is. It's really fast. You need to add a whole lot of zeros before this one starts slowing down. And this slowdown is probably not because of the progress bar, it's because of this number of computations it needs to do in the background. Right, so this is the example then on the async task. So if you can just quickly run through it again, your async task gets declared with the extends async task with these generic types. So an integer first means that this is the value that will be passed in. It's this value there that you pass in. What is the type of that value that you're going to pass in? And that type there will also be the type that your doing background will accept. Your second type there, this integer, has got everything to do with your on progress update, on what value gets passed in here. And because we said publish progress I, which is using an integer from the for loop, then this type must be integer. And then the last part there, string, is what your async task basically returns back. And it's for your doing background method. Your doing background method will then return back a string, and it will return it back with the return statement back into your on post execute. So this type there, what you accept in your on post execute, as well as what you return back in your doing background, is what this type indicates. And then just remember that your on pre-execute, as well as on progress update, as well as on post execute, all three of them runs on the user interface thread, while your doing background method is on a total different thread, and you cannot access your user interface from there. Well, you can using your publish progress method, which will call your on progress update, which is again in the user interface. So when will your on pre-execute run? Right at the start. Then your doing background method. While you are in your doing background method, you can call on progress update by just calling publish progress. And then when everything is done, it will end up in your on post execute. And this is normally where you will set your progress bar's visibility to gone. You will show some results, and you can show a toast or whatever you want to do. So now in some cases also what people do is they set with this progress bar, they will place some text underneath it to show you in values how far it is. So if you wanted to do that, you can just add a text view underneath your progress bar here, and then update that text view also in your on progress update. You can update your text view here by setting it. This is obviously your value where you're currently at, and your maximum value that you'll get from this value there is the maximum value that you'll have. So you can set it to a specific text view. We can say TV results dot set text. Let's set it to values at position 0. And then you can have something like, let's do that symbol there, and then we can have etdice dot get text, because now we're in the user interface thread again, dot toString dot trim. And then you can say, well, it's so many out of so many that we want to do. We can just quickly check this out, even though it's not going to work correctly. You can use your own text view there at the top to show you how far we are currently. Let's add a value there, roll the dice, and you can see there it shows on the text view. Let's run it so many times, and you can see there it updates. Okay, but remember it's only 5% at a time, so it's quite big values that it updates. So you can have that text view just directly underneath your progress bar, and then you'll get that values. Hope that you've learned something from this async task. This async task is very important for what we're doing next, which will be working with your SQLite database, where we need to also use the async task to do our calculations of the database in the background. See you in the next video.